Okay, in this video I'll be going over the test 3 review. So let's go ahead and get started. As you look at this first polynomial, we can see that it's not in descending order. In fact, that's our first step, is to put it in descending order. So starting with the highest power of x going all the way down to the constant, you would get f of x is equal to negative 5x to the fourth plus 9x cubed minus 12x squared plus 21. So our leading term is the term that has the highest power of x, so that would be x to the fourth. So our leading term is negative x to the fourth. Like if this had been our leading term, you would have to include the negative there. So make sure you always include the sign. So if our leading term is negative 5x to the fourth, the leading coefficient is just the number in front of the x, and so that's negative 5. The degree of the polynomial is the exponent of our leading term, and so that would be 4. Now, we learned that if we have a polynomial of degree 4, then we know we have 4 solutions, or zeros, counting multiplicity. Now, some of those could be real number zeros, some of them might be imaginary, or some of them could be rational, some could be irrational, but the total number of zeros will be 4, again counting multiplicity. Some of them may be repeated. The maximum number of zeros, again, would be 4. The maximum number of x-intercepts, well, we learned that our zeros and x-intercepts are essentially the same. Wherever our zeros are, we're going to have x-intercepts on the graph, so that would be 4 as well. Now keep in mind, if some of your zeros were complex or imaginary, then you would have less x-intercepts. The number of turning points, well, in this problem n is 4, or our degree is 4, and the number of turning points is n minus 1, so it's just 1 less, so that would be 3. This is a 4th degree polynomial, so we call that quartic. Cubic would be 3rd degree, quadratic would be 2nd degree, and so on. And then describe the end behavior of the graph. Now remember, the leading term is going to determine your end behavior. In this case, we're even and we're negative. The number out front's negative, and it's an even degree. And so we learned, when we think of even polynomials, or in this leading term that's even, think of the graph of y equals x squared, which opens up on both ends. If you have a negative out front, that means it goes down on both ends. So the end behavior here, because it's even and negative, it's going to fall on both ends. On number 2, notice we're odd and positive. And so remember, when you think of an odd degree polynomial, think of the graph of y equals x cubed when you determine end behavior. I called that the John Travolta end behavior, and that looks like that. It's basically the end behavior of the graph of y equals x cubed. All right. Let's look at number 3. It says find the zeros of the polynomial function and state the multiplicity of each. So for each variable factor, we're going to have a 0. So notice we have x cubed here. So x equals 0 is a 0. And since it's to the 3rd power, basically we have 3 factors of x. That means we're going to count that 0 3 times. Its multiplicity is 3. So x minus 1 corresponds to the 0, x equals 1. And since this has an exponent of 1, since there's only one factor, the multiplicity is 1 for that 0. For x equals negative 7, you have a multiplicity of 2. And for x equals 6, you have a multiplicity of 4. So again, we're just looking at these exponents here. All right, let's move on to the next slide. It says find the zeros of the polynomial function and state the multiplicity of each. Now, the one thing I just want you to recall, something that I said to you earlier, is you always want to use your factoring skills first, if possible. So in both of these problems, the skills we already have for factoring are all we need to find the zeros. We're not going to have to do any synthetic division. All right, so let's go ahead and look at the first one here. Notice f of x equals x to the fourth minus 3x cubed plus 10x squared. Well, when you're factoring, you should always look for a GCF first. And here it's going to be x squared. And so we just need to factor out an x squared from each term. So it'll be x squared times x squared gives us the first term. And then we ask ourselves, what times x squared gives us a minus 3x cubed? That would be a minus 3x. And what times x squared would give you negative 10x squared? That would be minus 10. So if we wanted to distribute or multiply, distribute it out, we would get back to where we started. So now notice this part here, that's a trinomial, and quite frequently we can factor those using the AC method. So here we would need two numbers that multiply to negative 10 and add to negative 3. Well, it's going to be 2 and 5, and the 5 should be negative, so 2 and negative 5. So this becomes x plus 2 times x minus 5, and don't forget the x squared. And so now we're ready to find the zeros. So if x squared is a factor, we know x equals 0 is a 0. In fact, you can see quite easily that if you plug in 0 into this function, it makes the output 0. And so since it's squared, 0 has a multiplicity of 2. Now notice x equals negative 2 and 5. Those are going to have a multiplicity of 1. All right, if you haven't already tried b, you should go ahead and do that. All right, so this has 4 terms, so factoring by grouping would be normally what we would do there. There is no greatest common factor here. However, if we factor by grouping, we can look at the first 2 terms and factor out an x squared. It'll be x squared times x is x cubed, and x squared times 3 gives you the 3x squared. And then when we factor these second 2 terms, if you do your work correctly, you should get a factor of x plus 3. In fact, we learn that you should always have the same thing inside the parentheses, or something's wrong when you're factoring by grouping. So now I need x times something to give me this negative 4x. Well, that's a minus 4. Notice minus 4 times x gives you the minus 4x, and minus 4 times 3 gives you the minus 12. So you can see that that does work. All right, so this, if you look at our 2 terms here, our common factor is x plus 3. We're going to get x plus 3 times x squared minus 4. Notice if you cross off these, you can see your x squared minus 4. And so now notice here you have a difference of squares. So we can factor that as x minus 2 times x plus 2. And so finally we have this in factored form. We're going to have 3 zeros, negative 3, 2, and negative 2. And notice they're all a multiplicity of 1. Now, on number 5, all I'm having you do is actually graph the b that we just did. And so notice it says without the use of a calculator. So just be careful not to overuse your calculator. It's important that you have these basic skills and that you show the algebra, or that you know how to do the algebra as you do these problems, so that when you move on to calculus, you'll be prepared. So anyway, here the first thing you want to think about when we did these kind of graphs is in behavior. So notice my leading term is x cubed, so we're an odd degree and we're positive. And so that's the John Travolta in behavior, which looks like that. Again, if you graph y equals x cubed, that's what the end behavior looks like. Next, we need to look at our zeros. Well, we already have all the zeros from B, so I'm going to do a Z and B chart. Remember, Z is for 0, M is for multiplicity, and B is for the behavior of the graph at that 0 or x-intercept. Remember, zeros and x-intercepts are pretty much one and the same. So our zeros are -3, 2, and -2, and they're all multiplicity of 1, which means on the graph, when you get to each of those x-intercepts, so notice the first x-intercept would be -3, 0. You'd have 2, 0, and -2, 0. Again, the x or the zeros are just these values here. So the behavior at each x-intercept is going to be that's going to cross. We learn if you have an odd multiplicity, the graph will cross at the corresponding x-intercept. All right, so now we're ready to graph. So the first thing you do is plot your points, and then you put in your end behavior, and then we know we're going to cross at each of these zeros. Now, you know what, before I go any further, I need to erase here. So let's erase this stuff right here. All right, so we're going to cross at each zero, but I want to talk about the y-intercept next. When you do the graphs in my math lab, I believe you're going to have to put in a y-intercept. So notice if you find f of 0 here, it's just going to give you that number, whoops, right here, whoops, -0, -12. And so as you do your graph, keep that in mind. So we're going to cross at -3. Remember, we go from left to right when we draw the graph. So eventually this graph's going to have to come back down and touch the x-intercept -2, 0. And again, it's going to cross there. And we're going to go down all the way to -12. And then notice when you get to 2, you are going to cross, which matches your end behavior there. All right, let's move on to the next slide. On number 6, we need to find the graph of this function. It's f of x equals minus the quantity x minus 1 squared times the quantity x plus 3 squared times the quantity x minus 4. It says find each of the following, then graph. So first of all, what's the degree? Well, we add the exponents on the factors, and so notice this would be a 1, and so we're going to get 2 plus 2 plus 1. Our degree is 5. Now we only do that when a polynomial is in factored form. Normally, if it's in standard form, we just take the degree from the leading term. Now in behavior here, since notice the negative out front here, we're going to be odd and negative, and so that's going to be the reverse John Travolta end behavior, or basically the opposite of the end behavior of y equals x cubed. And then next we're going to complete this Z and B chart. So if x minus 1 is a factor, we know that x equals 1 is a 0. The multiplicity is 2, and so we know that the graph will bounce at that 0, or x-intercept. And then if x plus 3 is a factor, we know that x equals -3 is a 0. Notice the multiplicity there is 2, since there's 2 factors of x plus 3, which means we'll bounce at that x-intercept, or 0. And then finally, we have x equals 4, multiplicity of 1, which means at that x-intercept we're going to cross. So let's go ahead and put in our points, and let's draw in the end behavior. Now going from left to right, when we get to -3, the 0, -3, 0, let's see, we're going to bounce. That's what this is telling us right here. And so we'll go back up. Eventually the graph will have to come back down to the next 0, which is at 1. When we get to 1, notice here we're going to also bounce. And then finally, when you come back down to 4, you're going to cross, and notice that matches the end behavior that's there. And so we're done. Let's move on to number 7. Given the polynomial p of x equals 6x cubed plus 7x squared plus 27x plus 24, and d of x equals 3x plus 4, use long division to find the quotient q of x and the remainder r of x when p of x is divided by d of x. Well, this is just polynomial division. We're dividing our polynomial by 3x plus 4, our divisor. So since this is long division, by the way, since this is not a 1, we would normally use long division. We can only use synthetic division when we have a 1x and we're dealing with something that's linear. If you're not dividing by a linear function, then, or a linear polynomial, then you'll have to use long division. All right, so let's go ahead and set it up. Oops, I forgot to mention one thing up on number 6. When you do the graph in MyMathLab, remember you'd have to find the y-intercept. In this problem, it's actually 36, so it'd be kind of hard to show it on the grid I gave you. But in MyMathLab, you're going to, I believe, have to put those y-intercepts in when you draw your graph. Okay, so now we're ready to set up our number 7 long division. So remember, we want to look at our leading terms, and we ask ourselves, what times 3x gives you 6x cubed? Well, that would be, let me go ahead and erase this. That would be 2x cubed, or squared, I mean. So 2x, and by the way you could always do this off to the side if it helps. You can write 6x cubed over 3x, and that would be 2x squared. And so that's another way that you could do each step if you can't do it in your head. Okay, so next I would, so now that I've got this 2x squared, I'm going to multiply times my divisor, so I'll have to distribute. 2x squared times 3x is 6x cubed, and 2x squared times 4 is 8x squared. Now we'll take this binomial and subtract it from what's above. 6x cubed minus 6x cubed is 0. And 17x squared minus 8x squared, don't forget you have to distribute this negative to both of these. So that's going to be minus 8x squared. We're going to get 9x squared. And let's bring down the 27, or the plus 27x. And then we ask ourselves now, what times 3x is going to give us 9x squared? Again, if you want, you could do 9x squared over 3x. You're going to end up with 3x here. Let me erase these marks. And so that would be 3x. And now we'll multiply the 3x times our divisor. You'll get 3x times 3x is 9x squared, and 3x times 4 is 12x. Let's go ahead and subtract. And let's see, 9x squared minus 9x squared, we're going to get a 0 there. And 27x minus 12x is 15x. All right, let's go ahead and bring down our plus 24. And we'll do this one more time. We need to ask ourselves, what times 3x gives you 15x? Of course, that's going to be 5. So now we'll multiply 5 times our divisor. 5 times 3x is 15x, and 5 times 4 is 20. When we subtract, notice 15x minus 15x is 0, and 24 minus 20 is going to give us 4. And so, let's see, we're supposed to get the quotient and the remainder. The quotient is our answer here. So that's q of x, and of course our remainder comes from this number right here, the 4. Now notice in part B it says to express the polynomial as p of x equals dx times q of x plus r of x. Basically, p of x is equal to your divisor, well that was 3x plus 4, times your quotient, 2x squared plus 3x plus 5, plus your remainder. All right, let's move on to the next slide. All right, and I think I'll actually stop right here and I'll do a second video.